Okay, today we are going to discuss a new topic, systems of particles and rotational motion. So what was happening earlier? Whenever we were discussing a numerical problem or a topic, we were considering the object to be a point mass. Let's say we were discussing about motion of a car. So if this car moves from a position to a new position and we had to find that what is the new position. So we were treating this car as a point mass or like a particle. In reality, this car is not a point mass. Rather, this car is made up of huge number of particles, or we can say this car is a system of particles, or this car is a system of particles. So, in general, we can say an extended body is a system of particles. So, let me write it here. Extended body is nothing but system of particles. Now, we are going to study about the extended bodies, means about their dynamics. So, to start with, we will keep our discussion simple and we will discuss about rigid bodies. So, what is a rigid body? A rigid body is a system of particles where, in simple, rigid body is a body which has fixed shape and size, and this means rigid body is a system of particles where all the particles have fixed position with respect to a particular particle or a chosen particle, which we can call a reference particle. So, fixed shape or size. And what do we mean by a reference particle here? Let's say we have a block here. Now, if we are saying that, let's say this is our reference particle, we have chosen a particle at this corner here. So all other particles in this block, all those particles have a particular position with respect to this chosen particle or this reference particle, and this relative position is not going to change. If we are moving this particle from here to here, new position, without rotating it, our reference particle will come here, but all these particles are still at the same relative position with respect to this reference particle. So, considering rigid body, we can keep our discussion simple for time being. Later, we are going to extend this concept. Now, motion of a rigid body. Motion of a rigid body. So, if we are studying motion, let's say we have a block here and this block is being moved on a horizontal surface without rotation. So this kind of motion is called translatory motion or translational motion. And we can add here pure translatory motion. Now, what about this motion? Let's say we have a spherical body here and this body is rolling over this surface and moving to a new location. So this body has both translatory motion as well as rotation, or we can say rotatory motion. Means both translational and rotational motion we can see in this body. How? Look, this body is changing position from one to another, and as well as the particles in this body are moving on a circular path about a fixed axis. Let me make it more clear to you. So, here we have this body, and if this body is rolling, it means this body is moving from one location to another. One thing is clear that it has translatory motion. Now coming to rotational motion here, let's say an imaginary line which is passing through the center of this spherical body. For convenience, let's take it as a spherical body. So all other particles which are constituting this spherical body, they all have a circular motion around this axis in a plane which is perpendicular to this axis. And this axis we can call axis of rotation. So this particle is moving on this circular plane. So these particles have one motion which brings these particles from one location to a new location, as well as these particles are moving in a circular plane, and that plane is perpendicular to this axis which we are calling axis of rotation. So it has both translatory and rotating motion. Now let's take one more example. What about a ceiling fan? Let's say here we have a ceiling fan, and this fan has a motion, and we know this is a motion where all the particles constituting this fan are moving in a circular path. All these particles in a circular path, and this is the axis of rotation. Means this is the axis around which these all particles are moving on a circular path. So we can say that this body is in rotation, and this body is not being displaced from one position to another position. So this motion is pure rotation or pure rotational motion. Now, in both the cases, whether we were talking about this situation where this body is moving from one location to another, or this situation where the body is not actually displacing from its initial position, rather it is just rotating about an axis. Both in both the cases, this axis of rotation is not changing its angle, or it is not tilting, doing any kind of motion like oscillation or something. Let me give you another example, then it will be more clear. Where the axis of rotation is not fixed, rather the axis of rotation is moving itself. Let's take this example. Let's take a stand fan here. So you may have seen that stand fan which is oscillating. In this case, if we have an oscillating stand fan, in this case, what happens? These blades are moving in a circular path, means the particles on the blade are moving in a circular path, and the axis of rotation of these blades is this one. And if this fan oscillates, it comes this way and again go back. So this kind of motion, here we can see that this axis is not fixed itself. This axis is oscillating. So this is an example of oscillating axis of rotation. And we say this is a rotational motion. Now, taking another example, we have seen a spinning top. Let's say we have a top here which is spinning, and this top is also moving on a circular path. What do I mean when I'm saying this is moving on a circular path? It means its axis of rotation, this axis about which all the particles constituting this top are moving on a circular track. This axis itself is not fixed. This axis is revolving around now. Such motion, such rotating motion or rotational motion, we call precession. So, in case of precession, the axis of rotation of a body is not fixed, rather, that axis itself revolves or rotates or oscillates.